this is John from caveofprogramming.com, and this is a tutorial on interfaces in Java. So there's a lot to say about interfaces, and we're just going to get started on them here in this tutorial. So let's say I create a class here. I'm going to create a new class, and I'll call it, I don't know, I'll call it machine, and I won't give machine any methods for the moment, but I'll create another class here, new class, which I'll call person. So I've got two classes here, machine and person, and machine might have, I don't know, like a method public void start, let's say. I'm just trying to create a sort of absolutely minimal, plausible kind of scenario for using interfaces. And I'll say here machine started, and person might have a bunch of methods too. I don't know what, like let's have a public void greet, and greet just says sysout hello there. In fact, let's give machine some, just to make this a bit more realistic, let's give it a private string, maybe a private int ID equals 7, and let's give person a private string name. And I'll also give person a constructor. I'm going to right click my class file here and go to source. I'm going to go to generate constructor using fields, tick name and click OK, and that will generate a constructor for me that sets the name and also calls the super constructor, which I don't need, so I'm going to get rid of that, because person will actually be a child of the object class secretly, because all classes are in Java. But anyway, now I can use these two classes, of course. I can say machine mac1, let's say, equals new machine, and machine's just got one method at the moment, so I can say mac1 dot, well, these are actually inherited from the object parent class, but I can call start, which is the method that I defined for machine. And to create a new person, let's say person1 equals new person, and person's got this constructor where you have to pass in the name, because that's what I just defined. I can say person1 dot greet, for example. Whoops, not equals. I want to call person1 dot greet. And so the point is that machine and person are just two completely different arbitrary objects with nothing in common. But now supposing I thought, okay, both machine and person should have a method called, let's say, show info. So for some reason I've decided that, okay, machine and person are nothing to do with each other, they're not the same kind of thing, they don't have a common parent class or anything like that, but I've decided that they should both have a method called show info. Java gives me a kind of mechanism to kind of formalize that, and this is one thing you can use interfaces for. So let's right click in my project here. I'm right clicking the default package, but I could also just right click the project folder, it doesn't matter here, and go to new, and instead of going to new class, I'm going to go to new interface, like this. And creating an interface is pretty much the same as creating a class, so I'll give it a name which should start with an uppercase letter, and I'll call this interface info, and I'll click finish. And I'm going to give this interface a method, so I'm going to say public void show info. I'm not going to pass the method any parameters, although I certainly could do. And the important thing is I'm not going to define a method body. Like I could in a class, I'd define something like, I'd open a bracket, curly bracket like that, and put a closing one in, and define code in here. But interfaces don't have any code, so they don't even have these curly brackets. All they have is the header of methods. This is the header, and that's all they have. No curly parentheses. So I define this show info, and what I can do with that is, let's say I go to machine, I can say machine implements info, like that. And if I do that without doing anything else, I'm going to get an error here. And if I look at the error, click on it, and go to add unimplemented methods, and I could also type this by hand. What saying implements info does is it forces you to have all of the methods with the headers that are specified in this interface. So I said, okay, if something implements the info interface, it's got to have a method public void show info. And now Eclipse has just filled in for me the body of this method public void show info. And this override annotation here, this is optional, but that's just checking that this really is an override. But I could delete that, I don't need it. I'll delete this comment. And let's put something in here. Let's make it do something like sysout machine ID is, and I'll say plus ID. Now we could do the same with person. I could say person implements info, and again the error comes up, and let's go to add unimplemented methods, and in person I'll say sysout person name is, and let's just output name there. So I'll leave that there. As I say, it's optional. Now the great thing about interfaces are, so far we're just saying that an interface is it's kind of like a text contract, really. The way we've used it so far, it's just like a thing that says, okay, if you implement this interface, which could have any number of methods in with different return types, different parameters, different names and so on, if you say implements that interface, then it's got to have the methods that you've specified here. So it's just kind of like a textual contract from that point of view. And by the way, a class can implement any number of interfaces. You can have a list of interfaces separated by commas here, as many as you like. And of course you can separately to that make a class extend some parent class, as you saw in the last tutorial. But a class can only extend one parent class, whereas it can implement lots and lots of interfaces without number. But the great thing about interfaces is that now you can use them basically wherever you would have used a class name. The only place you can't use an interface is when you do new, because when you do new, you're actually allocating memory to store kind of variables and methods, I suppose. I'm not really sure how it works. But when you do new, it's got to be followed by a class name, with some exceptions that we'll see in a future tutorial. So you can't do new and an interface name normally without doing some other stuff anyway. But anywhere else where you've got the name of a class, you could use the name of an interface. So let's take an example. I could say info 1 equals, for example, new machine, like that. It will let me do that, and the reason I can do that is because machine does implement this interface up here. It says implements info, and when I've done that, this is a variable of type info pointing to an object of type machine, and I can only use this variable to access just the one method of machine. Okay, here are a bunch of methods that are kind of in the object parent class of all objects, but the only machine specific method that I can access is the one defined in the interface, this info interface, which is show info. So because I define show info in this interface, I can call it via variables of the interface type. And of course I could do stuff like info, let's say info2 equals, and I could point it to person 1, because person 1 is actually a reference to a person object. So I could point this reference of type info to that person object, because person implements info. So I've got this one person object here, person 1 points at it, and now I'm saying point info2, this variable, to the same thing that person 1 refers to or points at. So again, I could say like info2.showInfo, and if I run that, it's going to say run as Java application. I think I'm running the wrong thing. No, that's good. Okay, and this is calling the showInfo method in this person object. So if that's confusing, which it probably is if it's the first time you've seen it, it's worth spending some time looking at. And I'll show you one more good example here. So so here I've got this class called app, which is just serving as a place to put my public static void main method. So I've not got an app object, but I can create a method here, like private static info, let's say, and I can make this method take a parameter of type info, and I need the return type there, let's say void. So methods aren't usually static, these methods aren't static, but I have to make this static if I want to use it, because there's no app object here. I haven't done new app, and that's why I'm making it static. And in here I could say info.showInfo, because that's all you can do with this info interface, because I've only defined one method in it, although I could define more. You could have as many methods in there as you like, as I say. And now I can call info. I don't know if it's getting confusing having all these infos. Let's call this something different, like output info. Maybe that's better. And I can call output info, and I could pass, for example, there's a range of possibilities. I could pass machine 1 to it, for example, because machine 1 implements the info interface, or I could say output info person 1, for example. And so I can pass any object to this method that implements this info interface, and then within the method I can access any method that is defined in the info interface, but I can't access other kind of methods of the class. So there we've got this stuff coming out again. Let's maybe just put this out in here, blank line, to make that a bit clearer. There we go. So we're producing this by doing this. So that's as far as I can think, that's sort of almost all there is really to interfaces, to the mechanics of interfaces. And of course this doesn't tell you much about how they are used, but we're seeing one possible usage here, that if you want to pass disparate different objects to a method, as long as they implement the same interface, you can make it possible, and you can call methods in those classes, those objects, by using the methods of the interface. That's one possibility. There are other things you can use interfaces for. If you want some examples, you could look, for example, at I've got some free tutorials on YouTube or on my website, caveofprogramming.com, of the collections packages in Java that are used for kind of storing and manipulating data. And they group the different storage objects down under different interfaces like list and set and map and so on. So that's another use, is to kind of group objects in a way. And another kind of possible use is some people actually design whole programs by using interfaces. Like, for example, if I think, you could start off designing a program by thinking, okay, what classes do I need? And then I'll say, let's say I want to have a class, not a class, well, let's say I'm going to have objects that all, for example, have methods like start and stop. I could do stuff like new interface, and I could call this, like, I don't know, startable, for example. So I just stands for interface, which you could use if you want to make it clear that it is an interface. And then you can start defining stuff like public void start here and public void stop, and these could have parameters if you want, and so on. So some people design whole programs like that, and they create the interfaces first, so that you're defining how the objects will interact with each other, and then you just create objects that implement those interfaces, which is, I don't know the name for that technique, but it's a perfectly reasonable thing to do. And now there's just one more thing that I wanted to say, which has almost slipped my mind. Let me think for a second. Okay, got it, yeah. What I wanted to say was just like, there's this really, I think it's a really nice analogy that I thought of for interfaces. So I'm not going to show you any more code now, but if you want like a way of thinking about interfaces that I find useful, you can always think that if you open a bank account, then that's kind of like doing new with a class to create an object. When you open a bank account, usually you look into what bank you're going to use, and you might look at their, I don't know, interest rates, or what kind of what kind of perks they give you, or whatever, where their branches are located. You kind of look into the bank and think about it. But after you've opened a bank account, then you sort of no longer really think about the particular bank. You just expect that the bank will have certain facilities that every bank has, like facilities for withdrawing money, for paying money in, I don't know, for cashing checks, all this kind of thing. So the facilities that the bank has are kind of like the things that you specify through the interface. And you only have to think about particular objects when you do new. So if you look at this example, for example, I'm saying info1 equals new machine, and by doing that, I no longer have access after this to machine specific methods except for the ones that I define in my interface. And I could have done info1 equals new person or something, and then I would have had access to the show info method in person. But it's kind of like sometimes you only care about what particular kind of object you're creating here when you do new, and after that you just care about what methods the object has. You don't worry about the type of it anymore, and you access those methods through the interface. That's kind of just one way of working. It's not how you always work. But I like this analogy because if you look, for example, at the Java collections, you'll have the list interface, and you only think about what kind of list you're creating when you do new list, and new array list, new linked list, or whatever. And then the details, of the particular type of list, you sort of then slightly forget about, and you access that object through the interface methods, and all lists have kind of the same methods like add and remove and so on. So I don't know if that analogy helps, but if you do look at Java collections packages, I think it does kind of help to think, you're only going to worry about the particular type at the time when you create it, and later on you just worry about the interface, the actual methods that it has, which could be the same for a whole variety of different objects. Anyway, I'll leave it there because I'm waffling, and in the next tutorial we're going to look probably at packages in Java. So join me again then, and this code will be on caveofprogramming.com, and so join me again next time, and until then, happy coding.